This is part 2 for the Panasonic PV4361 that I got working in the last video, where it had the power supply issue. A couple capacitors were bad, but this one's also got some other issues we're going to deal with in this one, such as cleaning the mode switch, checking a few other things out, lubricating it and so forth, and basically just getting the thing in as good a condition as I can get it, considering the age of the machine. Let's check it out. This is part 2 for the Panasonic that we looked at in the previous video that had the power supply problem. As I said, I was going to lubricate the chassis and clean it up and see what needs to be done. I don't know whether this has had any work done on it in the past. I'm using a different microphone this time. I'm actually using the lavalier mic this time, clipped onto my collar, and the transmitter's in my pocket. So if there's any difference in the sound, that would be what it is. We're going to start by removing the front faceplate. Hopefully do it without breaking it, because the plastic on these it's bad. It's bad. These were terrible. I mean, they would break just by looking at them when they were still relatively new. And as I say, well, this plastic doesn't get better with age. Trust me on that one. The front door's already been broken off this one. Look at all the dust on here. Disgusting. First things first, we're going to pull the chassis, as I want to pull I don't need to pull the board or anything out. I want to pull the chassis so I can see the mode switch and stuff down below. I don't know whether it's ever been done. I don't know whether this drive IC has been soldered or not. We'll cross that bridge once I get the chassis out. But to pull the chassis on this, we're going to remove the required screws, and then the entire chassis will just pop out. I say this one needs a good bit of lubrication here. It's dry. This is all dry. This has never been done, I don't think. Doesn't look like it's ever been done. It looks like the original black libnium type of grease that they used to put on at the factory. So we need to get to the screws on the bottom. And at least on this one, I don't have to remove the cover. No booby trap on this one, just that one screw there and these two screws up here. You know, when I was editing the other video, smoke alarm kept going off in the house. I wondered, why the hell is that smoke alarm going off? And I go upstairs because the upstairs smoke alarm's going off. Why does the smoke alarm keep going off? Well, it could be because it's 22 years old, so I went out and bought a new one. But there was a window open, and there's some smoke in the air here from the wildfires. And I guess the wind has shifted a bit and it's blowing down my way, and I think some smoke got in the window. There was a fan in the room blowing the air from the room out. I run a couple fans around here just to keep the AC system working properly, because at the top of my stairs it's kind of a dead air space if the bedroom doors are all closed, which they usually are except for one. But I think what happened was some smoke got in from outside, and the fan blew it into the hallway, where it got to the smoke detector and caused it to trip. Doesn't look like this has been done on this one. This IC looks like it's been resoldered at one point. You can see here. So that was a trouble area on these machines. These would have a tendency to crack, and then the capstan motor would do weird things. The belt is in good shape. The mode switch doesn't look like it's been done. It doesn't look like it's been removed and put back in, because usually when these are done, people don't generally dress the wires back quite as well as they were at the factory. Plus, you can tell if the switch has been unsoldered, especially if someone used a solder wick on it. You can tell, and that does not look like it's ever been done. So we're going to do the mode switch on this one right now. It's going to start out we're going to make sure it's in the home position. So we do that by just making sure that the little hole there is lining up with the little dot. See, it was back a little too far. So it probably is dirty. So we set that there. Now we know that we're in the correct position. I'm going to heat up the iron. We'll undo the connections on the back here using the good old solder sucker. And pop the switch, clean the switch, and then I'll throw some lubricant onto the chassis and make sure this thing's good for another few years. Anytime you're working with heat in any of this area, you got to make sure that you don't make contact with this outside, it's like a plastic rim on the motor. But it's a magnetically encoded, think of it encoded like an audio tape with a tone in it, just a continual tone. And that is actually picked up by this little head over here, which if it looks like an audio recorder head, that's because that's exactly what it is. It looks like a standard little audio head. If I were to take it out, it would look exactly like a magnetic tape head. And that picks up the encoded magnetic signal that's in here, which is just a tone. That determines the speed that the motor is turning. It's a frequency generator. If you touch this with something magnetic, such as a magnetic screwdriver, or you touch it with your hot soldering iron, you will kill the magnetic field, and then you'll have speed instability. Every time the capstan motor turns, it will lose the signal and it will go out of lock. So be careful when working around here with anything that's hot. And that includes, don't flick your soldering iron around or anything, because hot solder could fly off the end of it and land on here and destroy it. I know all about that because I've done it. I had that happen on a customer's machine years and years and years ago when I was working in the shop and we had to replace the motor. What had happened was, just like that, I was using one of these manual tools and I went like that. And when I went like that, some solder that was on the end of the tip fell off and landed right on the edge, and it ruined the motor. So I'm just warning you, because it happened to me years ago. Keep your iron and anything that's hot on it that might fall off away from the motor. I still got some idiot arguing with me about Class D amplifiers. I had someone write me a book telling me how wrong I was about a Class D amplifier, calling it digital. Of course it's digital. You didn't think I wouldn't talk about this, did you? Of course it's digital, okay? A Class D amplifier is digital on the most basic form of being digital. It's a 1 or a 0. That's it. The incoming audio signal, I know people will say, oh, but it hasn't got a unique code attached to it. No, it doesn't. It's not pulse code modulation, it's pulse width modulation. Most basic form of digital. The incoming analog signal is sent through a comparator and added to a triangle signal that will switch it as the waveform crosses 0, it will switch it either on or off. It produces a pulse width modulation pulse train, which is then amplified by the output transistors to several volts or several hundred volts, depending on how powerful the amplifier is. And then that signal is filtered back away. The carrier basically is removed. And what you end up with an analog representation of that signal. But it's still digital because it's a 1 or a 0. A 1 or a 0. It doesn't matter. It doesn't need to have a code assigned to it. That's only if you're storing it on a retrieval system, such as a computer file or on a tape or any other type of storage. You assign an actual number. You measure the signal and you assign a number, and you measure it thousands of times per second and you assign a whole bunch of numbers. That's called pulse code modulation. A Class D amplifier is not coding anything. It is just taking the analog waveform and it is turning it into a 1 or a 0. Which eliminates all the distortions from linear amplifiers. You now have a pulse stream that is a 1 or a 0. which is why they are called digital amplifiers, because it's represented as a 1 or a 0. And the duration of that 1 or 0 changes depending on the amplitude. Almost like an FM radio signal. But every so often I get somebody who thinks they know more, and they spout off without really doing any research. So I have to put these people in their place. Oh, this is bad, this switch. You think it's going to make a difference? You can see what's come off that switch already. You see what's coming off this as well. There's the switch contacts. Just put another couple drops on here. This will keep the switch clean as it rotates. This is deoxit D100. Incidentally, what I'm using, D100L, is what I use on this type of stuff. Spin it a bit. And we're going to line the two arrows up right there. And that'll then put this little hole in line with the arrow on here. Put the, whoops, moved it. Put the switch back in and drop it in position and make sure that the alignment is correct, which it is. I can drop the screw back in and now re-solder the connections. And then we'll lubricate the mechanism and reinstall it, and that should probably do it for this machine. Just like that. And then these go around here. And then around the other side. Okay, I've got lithium grease. We'll just throw some grease in on the chassis here on parts that mesh together, like the gears down here. A little bit in the gears and in the slide. And some more in here. Don't need a lot. It will work its way in once it's going. We'll put some on the bottom of the track and again on the top. Put a little bit down here on the front loader. Probably don't need it on that gear, but a little bit on that one. And the worm gear here should get some grease on it, which I should have done that before I put the switch back in, but that's okay. We can get some in here. Just go down there like that. And that'll get some grease in that, into the worm gear underneath here. Put a little bit on this gear here, and then this will work its way into the worm gear when it goes around. Okay, that should probably be enough for the lower portion of the mechanism. We'll put a little bit on the top side as well, where the guides move. One place we do want to put it is on the tower gear, and this gear down here. But the tower gear is the biggie. That's the one that has a tendency to break. We'll just pop off the top of the pinch roller retainer, lift off the pinch roller, and yeah, we'll put some on here and put some on the shaft here. Normally you'd clean this off, but I can't be bothered. It's not dried, so I'll just throw some on there, and we'll throw some on the tower gear here. And in the back groove. And down here. And the fan gear. I think that's probably everything I need to. Oh, is there more? I think that's it. I think that's the critical parts I've got. So put the pinch roller back in place. There's been that part of the groove there as well. And put this top back on. Okay, I think it's time to drop this back in place. And check it out. Oh, you know what? I should put some more. Grease down here on these gears down here. These ones also need it. It doesn't need much, just a little bit. Just that once this goes down, it actually rides against the smooth part of the gear here. So just to give that just a little bit of extra lubrication for when the tape goes in. So a couple of switches on here, just making sure that they're activated a few times. That's the record lockout switch. So, oh, that's the record lockout. That's cassette down. That's the record lockout switch. Take up and supply spools. Note this machine does not have an optical sensor on the supply reel, only the take-up. Drop this back in place. Just line up the connectors and plug them in. And then this should just drop in just like that. They were pretty simple to put these machines together. In fact, this was probably one of the first of the VCRs that were assembled by robots. This screw is kind of an important one because it's grounding. If that one is loose, you can get interference on the screen. So you want to make sure that that screw is at least snug. As when the top cover is attached, being metal, it's grounded to the bottom plate, which is grounded to the chassis and the power supply. And one of the screws that goes into the back actually grounds into the power supply here. So the power supply is grounded here. Make sure that screw is snug. And it grounds to the back cabinet here, and the back cabinet grounds to the metal plate on the bottom as well. And that gives the machine excellent shielding from interference. That's funny, you know, Panasonic They had their GAO television back in the 80s. That was a CRT set, obviously. And 80s and late 80s and 90s. They had the Prism set first, and then they had the GAO set. The GAO, that's how they like to pronounce it. GAO. I think it meant King of Picture, if I'm not mistaken. That was the translation loosely. They were one of the first TVs that used a switching power supply. And what we were finding is people would get these two purple bars on the left side of their screen. And we'd move the VCR out from underneath the TV and it went away. And they actually came out with a piece of foil, like MacTac shelving, kind of like the foil tape I've got. I've got the 4-inch wide duct tape type stuff for doing duct repair. But they came out with one that was like the width of the stand. It was cut, and you peeled it off and you stuck it onto the bottom of the shelf that the VCR sat under, and it shielded the VCR. Didn't have any problem with these ones. It was when they went to the plastic top machines that they had all the problems. Video head was picking up interference from the TV. And these ones here, of course, when I ran it earlier, I was getting interference from the plasma until I put the top cover on it, and then the interference, of course, went away because the metal case, of course, will shield it, right? So we'll plug this back in to the TV and just do a few tests on it, and then that will get this one back in service so that it can go back in storage for whenever I might need it or might sell it or whatever I do with this one. As you can see, the display is not too bad. Not too bad at all with the front cover off. It's readable. A little quieter than before. If you remember the last time, it was ticking when it was loading. Get the TV on, make sure that everything is working, which it is. Maybe I'll check the waveform. I'll look at the RF from the heads, just make sure that I don't need to tweak anything before I put it together. I should probably clean the heads too. I haven't cleaned it, so I probably should do that first. Maybe we'll do that. Stop eject. Now it's nice and quiet. I'll clean it first, and then we'll put the scope on it and make sure that the alignment is correct. Yeah, you think it was dirty? Yikes. That looks like an aftermarket head. I believe that at one point, before it got smudged, said Manelco for Main Electronics Corporation. That was what his sticker kind of used to look like. A little stamp. He had a little red stamp that he put on all his replacement video heads that he sold. On this machine, this is your test points. Test point 2 is your RF, and this one here is whatever that one says on it. Anyway, that's the trigger point on these ones. I don't generally tell you which one to hook it up to, just because every machine is a little bit different. So you pretty much have to just wing it, hook up and take a look and see what the signals are and hook your scope up accordingly. This one here, the signal is a little bit down on the, well, we'll see it in a second here. I'll slow the shutter speed down to 1/30th of a second just to make it easier to see what I'm doing here. So you can see there's a little bit off on here on the level, so we're going to adjust the entry side and exit side guide to try to bring this up a bit. Almost looks like there's a spot of dirt on there is what it looks like. We'll just take a look at the drum. And there's the exit side. Just going to take a look at that drum. It might be a little bit of dirt. Something is causing the signal to drop after the beginning of the waveform. Right at the top of the picture. Don't see it, but the waveform is certainly dripping a bit. Usually what causes that type of symptom is a little bit of crud along the ledge, and you can see right down here, there's a little bit of crap right along that edge there, and that is enough, believe it or not, to cause that waveform to distort ever so slightly. So we're going to clean that out. We'll do that with a Q-tip and some alcohol. Make sure that the video heads themselves are away from the area where I'm going to be putting the Q-tip. We're just going to try to clean this crap out of this little groove here. And as you can see, the levels are much better. My shutter speed is a little bit on the slow side there. We'll just bump it back up here a bit. I guess I can't do that while I'm recording. Okay, back to auto. Anyway, the disruption caused by that debris is gone. And it's playing back my color bar tape perfectly. Well, as perfect as VHS can play. Because, I mean, VHS is crap. Everyone knows that. VHS always has been kind of a crappy format. It was never great, but that's about as good as it's going to get for a VHS format. Levels look good. The two heads are relatively well balanced, so they're not excessive wear, and this machine should be good for a while. And then the heads clog. Now the clear again. Anyway, this machine is done. The alignment is correct. It's clean, lubricated, and the mode switch is now clean. It was filthy before, as you saw. So now it's just a matter of putting the front cover on. Don't have to worry about the tape door because there isn't one. So just snap this on. Just like that. Throw the top cover on it, and it is good to go. Thanks for watching. We'll catch you in the next one. Bye.